Law of cosines. This is another law that we can use to find missing pieces of triangles that are not right triangles, of oblique triangles. First thing we're going to do is we're going to derive it. And to derive the law of cosines, obviously it needs to be a different way than the law of sines, or we would get the exact same answer. But I am going to still start by dropping the altitude, because we're going to derive this from right triangle trigonometry that we already know. Oh my gosh. Okay. I'm going to go ahead and list a couple things first. Let's see. The sine of C, sine of angle C, is h over a. And instead of doing the sine of something else, this time we're going to do the cosine. But we're going to stay with the same angle, C. Now, I need to know what the bottom length is, and I don't know what it is for this right triangle, so I'm going to give it a variable. And then because I'm doing that, I'm just going to go ahead and label this point D. We had it labeled before, but I didn't with this one. I'm going to call this little section right here X. So my cosine of C is X over A. Now I can rearrange these so that I have H equals A sine C and X equals A cosine C. So it's kind of the same thing that we did with law of sines as well. So the right triangle we were just doing stuff with is the pink one. Yeah. Now I'm going to do some stuff with the green one. This is the green one is a right triangle, and C squared is equal to H squared plus this bottom side squared. I do not have a variable for this bottom side. Anybody have an idea? No, we don't have time for that. The entire length is B. The right portion is X. I'm going to call this one B minus X. So I'm using things that are already there. I don't want to put in more variables if I can help it. So B minus X squared, I've just used the Pythagorean theorem to just talk about that green triangle and say what the C squared is equal to. And then from there, because we were talking about C, it has H's in it and X's in it, I'm going to go over here and use what X equals and what H equals, and I'm going to substitute. So I'll have C squared equals H was A sine C squared. And then B minus X, so I'm going to have B minus A cosine C squared. So just substituted what X and H are equal to. The B is still there. I'm going to simplify this. I'm going to square the stuff. So I've got A squared sine squared C plus, so this one I have to use that FOIL method. So I used my FOIL method, and I got b squared minus 2ab cosine c plus a squared cosine squared c. One thing that when I was doing this by myself, preparing for today, I just happened to notice these two terms look a lot alike. They're not the same, but they do look a lot alike. The next thing that we actually do is write them next to each other. And the reason why I wrote those next to each other is because if I factor out a squared from just those two terms, I get sine squared c plus cosine squared c. I don't have time. Oh my gosh. Hello. Can you tell me who you are? Okay, yeah. Bye. Okay. So sine squared c plus cosine squared c is 1. Remember that? 1. So we get c squared equals a squared plus b squared minus 2ab cosine c. And this is a version of law of cosines. The a, b, and c, that just depends on what information you have in which triangle, or in the triangle you're given. Again, it could be x, y, and z. It doesn't have to be a, b, and c. The c doesn't have to be first either. So what you need to know about this formula is that the side and the opposite angle are at the opposite sides of the equation. See how the c and the c's match? Everything else are the other two sides, and it doesn't matter if a or b comes first. It doesn't matter which one those are, because a squared plus b squared and b squared plus a squared are the same. Here, a and b doesn't matter which one's first, because if you multiply them, commutative property can multiply in any order. So what really matters is that the c, whatever letter it is, and the angle c, or whatever letter it is, are in the opposite spots of the formula. You can rewrite this formula so it is solved for cosine of that angle, but we're just going to do that. I'm not going to use the formula. I'm just going to do it while I work through it. So we've got two cases for this. One is if you have 3 sides. If you have 3 sides, then you're going to solve for the 3 angles. You can only do one at a time. So why don't we do angle A? Sound good? Angle A? Okay, so angle A, if I'm solving for angle A, opposite angle A is side A. So in the formula where I circled the C in the angle C, that's where my A's are going to be. So side A is 8. So we're going to do 8 squared equals, and then we have the other two sides, 14 squared plus 19 squared. It doesn't matter which order you write them. Minus 2 times 14 times 19. Doesn't matter which way, the order you add those, or multiply those, sorry. Cosine, and then it has to be angle A. It has to be what's opposite of the 8. So I'm gonna get cosine A by itself by undoing the 14 squared, by undoing the 19 squared. So I'm going to have 8 squared minus 14 squared minus 19 squared equals negative 2 times 14 times 19 cosine A. And then to undo the rest of it, we have to divide by it. And just thinking ahead, and just because of time, I am going to have to use cosine inverse so I can just get a by itself. So I'll go ahead and do that as part of my formula. So I'll be doing 8 squared, cosine inverse 8 squared minus 14 squared minus 19 squared over -2 times 14 times 19. So that's what I'm going to type into my calculator here. And I think I already have it typed in. Yeah. So I just have it typed in from earlier. You can see, I mean, you guys can type stuff in your calculator as well. Make sure you know how to do it, especially if you have the older version. Those are the people that I worry about the most, because if I'm using shortcuts and you don't have those, I would just want to make sure you can type it in correctly in your calculator as well. The answer when you type it in should be 22.075. 22.075. And this might be one where we would want to store it. Maybe, maybe not, but you might want to, because we are going to need angle A to get another angle at the end when we do 180 minus 2 angles to find the third one. Okay. I'm not going to go through this entire question because you really don't need to see this a million times. At this point, if I have angle A, 22.075, I still need to find angle B or angle C. What could I do? I could do law of sines if I want, because now I have an angle and its opposite. So I could do law of sines. Or I could just do law of cosines again, but choose a different number to start. And that's what I did for my example, because I can like just copy and paste the question on my calculator and just change a couple numbers. So that's what I did, but you can use whatever method you choose. I wanted to find angle B next. So I started out with, I lied. I was finding angle C. Just kidding. I want to do the one that's on my calculator so it doesn't take me extra time to type it in. Sorry, guys. I found angle C next, so I started with 14 squared equals, and then I added the other two, 8 squared plus 19 squared, minus 2 times 8 times 19, cosine C. To solve that, we will have 14 squared minus 8 squared minus 19 squared divided by -2 times 8 times 19. And then you need to do the cosine inverse of both sides. So that would be what I type into my calculator, what I have typed into my calculator already. So I have that one typed in, I hit the enter, and I got 41.124. 41.124. So if you have two angles, you can find the third one by the triangle sum theorem. 180, subtract the two angles, use the full version of the angles, do not use rounded answers. All right. Another example of law of cosines is if we have side angle side. So here we have side angle side. I need to find angle A, or sorry, side A. That is across from the angle 115. When I use law of cosines, I need an angle and the side that is across from it. So I'm going to start by saying a squared equals That's the part I'm going to have to solve for. And then my other two sides, 15 squared plus 10 squared minus 2 times 15 times 10 cosine 115 degrees. And there aren't any variables to solve for. It's already almost solved for. All I have to do is square root. So that's what I'm going to type in my calculator, or have already typed in my calculator. Okay. So I have it typed in my calculator right up here in blue, and then I hit enter and I got 21.255. It's just typing that straight into my calculator, 21.255. At that point, you could use law of sines to find the other sides. You could use law of cosines to find missing angles. You don't need to find the sides. I lied. To find you could do law of sines or law of cosines at that point to find the other missing angles. Okay, I'm not going to finish that one. And we're going to skip the next two. This one's pretty easy. This one we didn't even cover. I'm just going to go the last thing on here, which is called Heron's formula. It's a formula. You just plug stuff in. So if the bell, no, we still have 5 minutes, but for some reason, if the bell would ring, it's just a formula. The formula would be used if you have side, side, side. So if we have a triangle with all three sides, you could find the area of it using Heron's formula. So here's an example where we've got 43, 53, and 72. Not drawn to scale. It says you have to find this S value. S is add all three sides up, divide by 2. And you can trust me, it's 84. Then we use our area formula, which says square root, and we take our S value, which is 84, and then we have a parenthesis with 84 minus the first side, 43, 84 minus another side, 53, and 84 minus the third side, 72. That should end up as a positive answer if you've done everything correct. You don't need to type it in. I already have it typed in, but that's all I did was type that into my calculator. '90s, sorry, got excited. Okay,